How to find the epicenter of an earthquake. Scientists use triangulation method to find the epicenter of an earthquake. Triangulation is a way of determining something's location using the location of other things. It is used by geologists to find the locations of earthquakes. When seismic data is collected from at least 3 different locations, it can be used to determine the epicenter by where it intersects. An earthquake generates seismic waves that penetrate the earth as body waves, the P and S, or travel as surface waves, the love and right. P wave is a primary body wave, the first seismic wave detected by Seismograph, able to move through both liquid and solid rock. And S wave, the secondary body wave that oscillate the ground perpendicular to the direction of wave travel. They travel about 1.7 times slower than P waves. Because liquids will not sustain shear stresses, S waves will not travel through liquids like water, molten rock, or Earth's water core. S waves produce vertical and horizontal motion in the ground surface. And radio waves, surface waves that move in an elliptical motion, producing both a vertical and horizontal component of motion in the direction of wave propagation. Love wave is another surface waves that move parallel to the Earth's surface and perpendicular to the direction of wave propagation. Every earthquake is recorded on numerous seismographs located in different directions. A seismograph or seismometer is an instrument used to detect and record earthquakes. Each seismograph records the time when the first P waves and second, the S wave, seismic waves arrive. A seismogram is a ground output by a seismograph. It is a record of the ground motion at a measuring station as a function of time. Seismogram typically record motion in 3 Cartesian axes. In math, that is the X, the Y, and the Z. With the Z axis perpendicular to the Earth's surface and the X and Y axis parallel to the surface. From that information, scientists can determine how fast the waves are traveling. Knowing this helps them calculate the distance from the epicenter to each seismograph. To determine the direction each wave travels, scientists draw a circles around the seismograph location. The radius of each circle equals the known distance to the epicenter. Where these 3 circles intersect is the epicenter. Now let's have activity number 2, locating the epicenter of an earthquake using triangulation method. Let's go!